So we have clock with hours and the minutes. And we want to find the angle between the arrows. For example, like this. And we're given hours and minutes integers. So this is kind of trivial, but not so trivial, because you have to remember your school mathematics, like how many minutes we have in hour, and so we have 60 of them. And what would be the best approach to write this down? So how can we go from the minutes to the angles? And we have to know that the total circle is 360 degrees, the entire circle, and that we have 60 minutes in hour. So this is knowledge you required to know. And after that, we can find, for example, this, like from angle from 0, this one for the house angle, and this one for the minutes angle, and then do some math on them. So the difference would be this. So this is a school geometry. And let's how can we think about the corner cases, because it's sometimes HA is bigger than MA, hours angle bigger than minutes angle, and sometimes it's otherwise. So the basic simple if is just to do if one is bigger than the other, then swap, and then compute this difference angle. And after that, we have to know that difference angle actually can be bigger than, so for example, like this, as a difference, or maybe like this one. This will be the difference, and in this case the difference would be this angle, and we want this smallest, so we have to do 260 minus difference and compare this with difference itself, and then take the minimum. So this is one solution. It's very simple to think about. It requires you a little bit of debugging, because for the hours arrow you actually have to do adjustment with minutes, and these coefficients are not exactly the obvious one. Also this 6 is not very obvious, because you have to do the division 360 divided by 60. Okay, but this is not the end of this problem. Let's look at the shortest solution. I will show you this one, and it's about complete magic. So let's think about this problem a different way. The arrows in each minute, they go in a different speed, but we have the angle between them. And if we define the function of angle between the arrows, it would be something like 5.5 degrees time. So this f by O, f from t, this angle between the arrows goes in this step of 5.5 degrees. This is one way of looking at this problem. Another way is to define the states. We have 720 states of different hours and minutes. So each minute there is one of 720 states. This periodic function. And let's look at this Rust code. It uses this angle function like plus 5.5 degrees each minute. And then we have to find what minutes are we in today. And this is hours times 60 plus minutes. So this is total minutes we are in. And we do this modulus 720 because we only have this numbers of steps. And this is a state we are looking. And then we define it. So this goes on all of the successors from 0. And Kotlin goes directly to this math solution. So it goes hours times 60 plus minutes. This is total minutes value. So go total minutes hours times 60 plus minutes, and this is the total minutes we have, and the angle would be 5.5 times these minutes. Let's look at this again. So this times 5.5. This is angle between the arrows. And we obviously doing this modular operation because we have some overflows, and if we simplify it a little bit, we're doing 180 minus abs of this value minus 180. So to define the mean angle, we go in 180 minus v minus 180, and v goes from 0 to 360 degrees. This is how we go on without ifs. And this v This V is the angle between arrows, and it's equal this 5 times total minutes, and total minutes is hours times 60 plus minutes. So this is how it looks like. This is shortest variant. Obviously you can't write it yourself without thinking, and I have to tell it. This Rust solution use successors. It can use from a fan, but you then have to manually track the previous value. Okay, that's it for today.